Swayam Prabha. Digital India. Educated India.
Hello friends, welcome back to this lectures on engineering system design. In the last few lectures we discussed about the importance of system engineering, and in the previous lecture we discussed about the life cycle of engineering systems and some of the system design processes like engineering system V, stage gate process and spiral process. Today we will start the system design process. We will go through the different steps one by one on the design of engineering systems. As explained in the previous lectures, we start with the system design process with the identification of needs. So, the focus here is mainly on finding out the original needs, and then based on these needs we go to the operational concept, functional requirements, system architecture, and then allocated requirement for these systems. Once we identify these requirements for various subsystems, then we go for the detailed design and then implementation, and finally we go for the test and verification. So, this is the flow of steps involved in the design. We start with the need identification. So, we will try to see what are the needs we are trying to identify, or what are the needs we are trying to fill using this system design, and what is wrong with the current situation and why do we need this particular situation. So, that will tell us what are the needs to be addressed in this particular design. And another important part is that whether the need is clearly articulated or clearly understood, clearly mentioned or clearly recorded, the requirements and the needs of the customer. So, once we have these needs identified, we will go for the operations concept for the system. Since it is a new design, we need to identify some kind of operation concept which will actually help us to develop the system based on these concepts. So, in order to do that, what we try to do is to find out who are the intended users for this system, how they use the products or how they actually use these products, and how is this different from the present system. So, if we know these things about the users and their preferences and what should be different from the existing, we can develop an operations concept. Once we have this operations concept, we will go to the next level of functional requirements. So, what specific capability will we provide in this particular system to satisfy the customer requirement, and to what level of detail we need to provide these requirements, and whether all the element interfaces are well defined within the requirements. So, once we have these the answers to this question, we are actually having our functional requirements ready. Based on that, we will go for the design of the system architecture. So, here we will try to address what is the overall plan of attack, what elements make up the overall approach, and are these complete, logical or consistent. So, whether the overall plan of attack is consistent, whether it actually satisfies the requirement, and whether they are complete and logical will be identified and verified in the system architecture stage. And then we go for the allocated requirements. Since we have many requirements and many systems, so we have to allocate these requirements amongst the system components. So, we will try to see which elements address which requirement. So, we have to do a mapping of the requirements with the components or the physical structure. So, there we do a mapping to identify which are the elements which actually address a particular requirement identified by the customer. And then we see whether the allocation is appropriate, whether the allocation is appropriate or we have did an over allocation or an under allocation. So, this will be analyzed, and then there are any unnecessary requirements. So, we have to go through these requirements and see whether all the requirements are genuine and there are no unnecessary requirements which warrants an additional elements into the system. So, all this will be analyzed in this stage, and once we are comfortable with these requirements and allocation of the requirements, we will go for the detailed design, which again is not part of the system engineering, which is more of a component engineering focus. And this that the details are correct, do they meet the requirements, are the interfaces are satisfied, all these are done by the design engineers or component engineers. And once the components are ready and it is ready for integration, again the system engineer will take it over and then start assembly and then do the implementation. Then basically we will do a testing of the implementation will be tested basically for the to understand whether the solution be satisfactory in terms of cost and schedule, and can we reuse the existing pieces. So these things will be analyzed at the implementation stage, and once it is completed we will go for a test and verification. So basically we are try to understand or identify what is our evidence of success, and will the customer be happy with this particular system, or will the users needs whether all the needs of the users are met. So we will do a test and verification at the end of the design process to ensure that it actually satisfy the customer requirement. So these are the various steps involved in the design of the system. So in order to achieve this, we have divided this whole process of system design into 6 process or the 6 functions of design process. So these 6 functions are applicable across life cycle, and the first one is define system level design problem. So here we try to understand the whole problem from the customer's point of view or the stakeholders point of view, try to develop concepts for the system and try to identify the system boundaries, try to identify the requirements, and then prepare a originating requirement document. So the purpose of the first level of design process or the first function of design process is basically to define the system level design problem. The second function is basically to develop the system functional architecture. So here once we have this all the requirements identified, we try to identify the functions to be provided in the system and then provide a hierarchical structure for the functions, and identify all the functions and make sure that these functions are sufficient to meet the customer requirements. The third one is to develop the system physical architecture. So once the functions are identified, we try to identify the components or the physical systems which actually will provide these functions in the system. This stage is the physical architecture development stage. And the fourth one is the system operational architecture. So once we have the system, the physical system in place, we need to find out how the system will be operated, what are the operational requirements for the system, and then we develop an operation architecture which will satisfy the customer requirements. Then we develop an interface architecture. Since we have many subsystems in place, so we go for an interface architecture which will try to identify all the interfaces needed for the subsystem as well as to the external system, and ensure that there is compatibility with the standards and other requirements identified in the system, and make sure that there is no loss of data or loss of communication between the subsystems. And finally, once the system is ready, develop a qualification system for the system where we ensure that the developed system is qualified to meet the requirements of the customer. So in this process, in this course, what we will try to do is to go through all these steps in detail, try to identify what are the tasks involved in each stage or each function, and then finally we will develop the qualification system for the main system which will actually satisfy requirements. As I mentioned earlier, this is applicable throughout the life cycle of the system. So for any life cycle of the system, these 6 functions are applicable. So if you take the development phase or the manufacturing phase or deployment phase, we need to identify the requirement, we have to define the problem, we need to define the functional architecture, we need to define the physical architecture, we need to identify the interfaces, we need to identify the qualification system. So across the life cycle, these processes are applicable. So we will develop these 6 functions for each life cycle separately, and then identify the requirement for each life cycle and the function and architecture for each life cycle. So to come to the first process, which is the define system level design problem, which is the out of the 6 functions, this is the first one. So here in this stage, we try to develop the operational concept for the system. We try to identify the external systems which are external to the system being developed, and we will try to identify the originating requirements. We try to identify what are the objectives of the system and how do we develop the objectives hierarchy, and then we have to make the documentation for the requirements, and then how do we manage the requirements. So these are the steps involved in defining the system level design problem. We will go through one by one what are the steps and how do we actually do all these stages to achieve the system level design problem. So, as you can see here, the system level design problem, the major input is stakeholders input. So, we have stakeholders, it can be the customer, it can be the purchaser or the whoever is using it. So, their input is the major input for the system level design problem. They state their requirement, their application, their expectation from the system. Based on that, the output will be coming as originating requirements and operational concepts. So, the major input is stakeholders input, and then the major output from this particular stage is the originating requirements. We make a document which is called originating requirements document or ORD, and we have few operational concepts which can be developed further to satisfy the stakeholders requirements. So, this chart actually explains the various stages and what are the inputs and outputs for the each stage in the first function. As you can see here, develop operational concepts, this is the first stage where we have the stakeholders input as the major inputs, and we have an output from this particular stage as the operational concept. So, we develop operational concept, very top level operational concept, very abstract and without any much details. So, this will be the output from the first stage of develop operational concept. And once we have this, we use this as an input, operational concept as an input, and define the system boundary with external systems. Since every system is interacting with the external systems, we need to identify what is our focus, so which one we are trying to focus here. So, that becomes our main focus and that becomes our system of interest, and everything which is interacting with the system will define as external systems. So, this will help us to mark a boundary where within which we need to design the system. So, the second stage of defining the system boundary will help, the external system diagram will help you to identify the system boundary, the inputs and outputs. So, the main output from this particular stage is the definition of the system boundary, the inputs to the system and what the outputs going out of the system. Then we use the operational concept as well as the system boundary inputs and outputs, and this operational concept and stakeholders input will be used to develop the system objectives hierarchy. So, every system will be having some objectives to be met which is defined by the customer, something like the operational cost or the operational efficiency. So, these things need to be given a particular hierarchy. So, we cannot have same importance to all these objectives. So, based on the operational concept and the stakeholder input, an objectives hierarchy will be developed which will help us to have some trade off at a later stage in the design. So, the output from this stage is the objectives hierarchy, which is where the inputs are operational concept and the stakeholder inputs. Now, using all these outputs from the previous stages, we develop, analyze and refine the requirements. So, this is an important stage where we need to develop all the requirements and analyze and refine the requirements from the customer. So, now we have an operational concept, we have the stakeholder input and we have an objective hierarchy. Based on this, we will identify all the requirements needed for the system and then prepare the originating and system requirements. So, there are two types of requirement, one is the originating requirement, the other one is the system requirements. We will see what are these requirements at a later stage. So, this will be the output from this particular stage. Then we go for a analysis of this requirement to ensure that they are feasible and they meet the requirement. So, that stage is the ensure requirements feasibility. So, here the system engineering team input will be important because the system engineers knows what actually whether the system the requirements really meet the customer needs. So, the system engineering team input as well as the originating and system requirements become the input here and then do a design feasibility analysis. Once it is satisfied, we will go for the qualification system requirement because every system has to be qualified to satisfy the requirement. So, we will define the qualification system requirement and the output will be the test system requirement document. And once this is done, we will get obtain the approval of system documentation from the higher ups, and at the end of this we will be getting the originating and system requirements documents. So, this process function of system level design problem, we start with the stakeholders inputs and with an originating and system requirements document. So, this is the final output of this particular stage of development. This is important because the requirements need to be clearly defined and understood by the stakeholders as well as the system engineers. Any constraining requirement will be a problem at the later stage of design. So, we should make sure that the requirements are little bit flexible so that we can have some freedom at the later stage to make sure that the proper trade off can be carried out and the system designers are not too much constrained in development of the operational concept as well as the functional and physical architecture of the system. So, as I mentioned, the first stage is operational concept development. So, an operational concept is a vision for what the system is. It is a statement of mission requirements and a description of how the system will be used. So, that is a very preliminary or very abstract level of concept, where we just define a vision for what the system is, and it is a very simple description of how the system will be used. It will include information about how the system will be developed, operated and retired from the perspective of the system stakeholders, and a collection of scenarios and systems interaction with other systems. So, in order to develop an operational concept, we need to have to develop preliminary analysis or preliminary concept how the system will be operated and used, and try to identify different scenarios of operation. So, what are the scenarios under which the system will be operated, so that will give us some input on the requirements, different various kinds of requirements, and systems interaction with the other system, which is basically an external system diagram. So, these are the things to be included in the operational concept. For example, if you take the operational concept for landing on the moon, it is a very again at a very top level concept. We can have different concepts to do this. We can have a direct ascent method, where the mission will start from the earth and it will go on around the earth, and then again it will take off to the moon directly from the orbit, and land directly on the moon, and then take off from the moon, and then again come directly and come to the earth. So, this is one way of doing it, is a direct ascent. Or we can have an earth orbit rendezvous, where the earth orbit will be the first stage, and then it will go directly to the moon and then land on the moon, and then come back from the moon, directly take off from the moon, go one round around the earth, and then land on the earth. So, this is another possibility, another concept which can be employed. Or the other one is lunar orbit rendezvous, where the along with the earth orbit it will go one round around the moon and moon's orbit, and then come back to the land on the moon, then take off from the moon, and then come back to the earth. So, these are the different operational concepts for landing on the moon. This is the way how we start with the system design, because we do not have any concepts to follow, or it is a totally new mission. Then we need to identify what are the possible options, what are the possible concepts we can employ. Then take one of these concepts and then develop the next level, where we try to develop the operational scenarios based on which we can identify the requirements to be provided or the functions to be provided in the system. So, in order to develop operational concept scenarios, we will try to identify various operational scenarios which we can think of. For example, if you take the case of an elevator, which is very common in most of our buildings, if you want to develop a system for elevator system for a particular building with multiple elevators or a single elevator, we will try to make a very simple concept scenario, where we will say that okay, we have two elevators on two sides of the building or two different locations, and then these will be serving to different floors at particular frequencies or particular efficiencies or the performance characteristics. And once we have this, then we will try to identify okay, what are the different scenarios under which this lift will be operated. So, we will try to define these scenarios in detail, as much detail as possible, so that it will include almost all the details what we need to know about the requirements to be provided in the system. For example, we take the scenario of an elevator passenger lift. So, we try to define the scenario in detail. So, we will try to explain it that the passengers, including mobility, hearing and visually challenged, request up service. So, we are trying to include the disabled or the differently abled people also into this, so that the requirements to be met in the elevator will be different if we are not providing this particular requirement. So, we are including that also here. We are providing the passengers, including the differently abled people. They request the up service or down service. They receive a feedback that their request was accepted. So, unless they receive a feedback, they will not be knowing whether the elevator is working or not. So, it is necessary to provide a feedback to the passenger saying that yes, your request has been accepted, and we will give a feedback that the request was accepted, and then receive an input that the elevator car is approaching. So, not only that the request was accepted, it will also give an input that the elevator car is approaching, and then that an entry opportunity is available. So, it should be informed to the passengers that an entry opportunity is already made available. This is important, especially because of visually challenged people. They may not be knowing that whether it has reached and the door is open. So, we need to ensure that an entry opportunity is available, and then the passenger will enter the elevator car and then request the floor, and once the passenger requests for the floor, they should get a feedback that their request was accepted, and then receive feedback that the door is closing, receive feedback about what floor the elevator is stopping, receive feedback that an exit opportunity is available, and exit elevator with no physical impediments. So, it clearly explains the whole scenario of using an elevator by a passenger from the moment he requests for a service to the extent where he actually comes out of the elevator without any physical impediments. It is important to say all these words like including mobility, hearing, visually challenged, as well as exit elevator with no physical impediments. All these will define the actual requirements to be provided in the elevator. So, this is just one scenario. There will be multiple scenarios like this which will help us to identify various requirements. For example, we can define different scenarios like an emergency situation. So, what will happen if there is an emergency in the lift, that inside the lift or outside the lift. So, what are the things to be taken care of under this situation, and there is a fire in the building. So, if there is a fire, what will be the way in which the elevator should function, whether it should provide the service or it should stop at the point where it is. There are people inside the lift, what should be the action to be taken. So, for that what are the other requirements to be needed, what kind of communication system to be provided between the elevator and the building, between the elevator and the emergency response team. So, all those things will be identified in this scenario description. Similarly, auto close, breakdown, overload, maintenance, all these scenarios can be clearly explained using these scenarios. Then we can identify those requirements to meet the such requirements. So, this will ensure that we are taking care of all the requirements, all the scenarios, and ensuring that the lift which is being designed meets the requirements of the customer to meet the various requirements under various operating scenarios. So, to describe the scenario, we can actually use a method called input output trace. So, here the input output trace basically gives a pictorial representation of the scenarios. Here the vertical lines represent the interacting people, the passenger and the elevator or the system components, the system or the external system, and the horizontal arrows represents the communication between system and the external system. So, here the passenger is an external system and the elevator is the main system which we are interested. So, we can identify what are the requests going from the passenger, what kind of feedback is coming back to the passenger, and then what information is being sent from the passenger to the elevator based on the feedback given by the elevator. So, all this can be represented in a pictorial way, so that it is easy to understand for others, especially the design engineers. So, anyone going through this will understand the kind of interaction taking place between the system and its subsystem or the external systems. So, this is the input output trace for the scenario 1 which we discussed, we explained in the previous slide. So, that was about the input output trace for identifying the requirements for operational concept, and another factor we need to take care is the external system diagram. So, as I mentioned, the system interacts with the environment and other systems. So, we need to identify the boundary in which where we need to concentrate our design efforts. For that we need to have the external systems diagram. So, it is the model of the interaction of the system with other systems in the relevant context, thus providing a definition of the system's boundary in terms of the system's inputs and outputs. So, here we are defining the system boundary in terms of the system's inputs and outputs. The purpose of this one is basically to explicitly define the system boundary and needed interfaces. So, using this external system diagram, we will be able to define the boundary and the needed interfaces or the type of interface needed between the system and the external system. For example, if you take the same elevator system, you can see the elevator system is the main system which actually provide the elevator services, and there are other system like external system like passengers, they request and use elevator service. Maintenance personnel will be maintaining the elevator. Whenever there is a problem, they will be attending to the elevator when there is a breakdown or any other service requirements. So, they are the people again who will be interacting with the system. Then there is a building on which the system is, the main system is installed. So that also influence the design of the system. So this provides the structural support, it provides the necessary safety features, it provides necessary power connection. So this also is interacting with the main system. So we need to find out what kind of interactions are taking place between the system and the external systems. For that we will develop an external system diagram. So this actually shows the external systems diagram, where the main function or the main system is here given as the function which provides the elevator services. So the elevator system is the main system and others are the external systems. We can actually identify other external systems depending on the type of system. There may be many more external systems, but in this case we are considered the passengers as one external system, maintenance personnel as another external system, and the building as external system, then building regulations which actually coming through the building and again interacting with the main system. So you can see here the passenger will request elevator services, that is one kind of interaction taking place, and then they use the elevator and then will be giving input to the elevator, or they are taking output from the elevator, that is another kind of interaction taking place. Similarly, the maintenance person will be maintaining the elevator, so there will be some inputs and outputs going and coming to the this particular external system. Similar the building also. This is how we actually define the external system. So what we need to look at here is this main system, where we try to provide we are developing this main system. So we need to provide the interfaces between this system and other systems at the design level itself. We need to ensure that we are providing necessary interfaces with the external systems. We identify all the kinds of inputs coming into this main system, so that the interfaces are capable of providing this communication between the system and the external systems. This is standard way of representing the external system diagram. This is known as an IIT diagram. We will be going through this method of developing the system diagram at a later stage, which is modeling of the system using graphical tools. So I will not be going to the details of this at present. What we try to do is to identify the functions. The request elevator services is a function which actually is done by the customer. So there is an external system function. So we will try to identify what are the inputs coming into this particular block, and then what are the outputs going from this block. So which one this particular function is interacting with which particular output. So is there an output going from the system? You can see that there is an output going from here to the external system, and similarly the use elevator service is another function. So whatever the output coming from here will be coming to here as digital inputs, and then it will be going to the elevator services, and then there will be passenger environment as coming as an external input to this, and then the request emergency support and emergency message will be another output from here. So all these inputs and outputs and the interaction will be properly recorded in a pictorial way, basically to get a better understanding of the interaction between the system and the external system. So this kind of diagrams are used not only for external system diagram, but again for the functional decomposition and then the function structure and the physical structure of the system. We will learn more about developing this kind of diagram at a later stage, but I just want to explain that you can use this kind of diagram, IIT diagrams, to represent the external systems in the design stage. So the next stage is basically to develop the objectives hierarchy of the system. As I mentioned earlier, the stakeholders will be having some objectives which actually they will explain to the designers that this system should meet the particular performance requirement, particular operational cost limitations are there, or particular operational efficiencies are to be maintained. So these are the hierarchies, these are the objectives given by the stakeholder to the designers. But since there are many such objectives, it is impossible to have equal weightage for all those requirements, all those objectives. What we need to do is to have a proper hierarchy of the objectives and identify which are the sub functions which actually contribute to the main objective, and then give a particular hierarchy or weightage to each objectives, so that at a later stage if you want to make a trade off between the cost and efficiency, or the power requirement, or the weight, or the other physical requirements, then we can actually use this as a reference to make sure that we really meet the objectives without compromising on the customer's requirement. So the hierarchy of objectives that are important to the system stakeholders in a value sense are developed in the objectives hierarchy. So what we do here is to understand what the customer is willing to pay. So sometimes the stakeholders would be willing to pay to obtain increased performance on any of these objectives. So the stakeholders will tell, okay, if I can improve that particular feature, the performance or the response time or the cost, if you can reduce the cost, I will be ready to spend more money for the development stage. If the operational cost can be reduced, even if the development cost is slightly higher, the customer will be ready to pay for that. So designers should understand what are the willingness of these stakeholders in this regard. And then this is developed by defining the natural subsets of the fundamental objectives. For the fundamental objectives, we can identify some natural subsets and then we give different values to these objectives and make sure that we have a proper objectives hierarchy which actually meets the stakeholders requirements and their willingness to pay extra to obtain those particular requirements. So this hierarchy will be having 2 to 5 levels normally. Additional information like value weights, value curves, etc. are added for each objective. It acts as a cornerstone for trade-off studies. As I mentioned earlier, if you want to make some trade-off, so they can be used as a cornerstone, and based on this we can decide whether to go for a trade-off or not. This is to be developed for each phase of the life cycle of the system. So that is important, for each phase of the life cycle we develop this kind of objectives hierarchy. This is an important tool in the decision making process, because at the later stage if you want to make some decisions about trade-off or any other decisions under uncertainty, then this will become an important tool for the designer. So this diagram shows basically objectives hierarchy. So as you can see here, there will be operational objectives which are defined by the stakeholder, like the monthly operating cost should be $1,500 to $1,000, or the operational performance objective like that the elevator should respond to the customers the passengers request within 1 second or 5 seconds. So these are the operational performance objectives and these are the operating cost objectives. So when you have an operating cost objective and the operational performance objective, we need to define, we have to decide, so what should be the weightage for this. So here you can see that operational cost weightage is only 0.1, more weightage is given for the performance objective. So even if the operating cost is slightly higher, the customer or the stakeholder is willing to pay more for operational performance objective. That is why this is given a higher weightage of 0.9. Now if we want to make these operational performance objectives, we need to identify what are the other sub objectives or the other functions or objectives which actually contribute to this main objective. So we identify all these objectives and then give weightage to each one, like the time in system, the ride quality or availability of the elevator. So in the case of an elevator, we can find out how much time is taken by the elevator to move from one floor to other floor, which is represented in terms of time in system. Similarly, the ride quality, how comfortable is the ride inside the elevator, and availability, how much it is available to the passenger whenever it is needed. So whether the availability is good, availability is there or not. So these are the three things which actually decides about the operational performance objective. So again these three we need to give weightages. So depending on the, again based on various analysis, there are various analysis tools which can actually be used for this weightage. So based on those analysis we will be doing the weightage, the time in system objective 0.35, 0.3 and 0.35. Again this depends on the designer, based on his own understanding and some analysis he will decide what should be the weightage to be given for each one. And again we can find out the other sub objectives or the which actually form to this main one. So the time in system, we can see that average weight for priority and routine, and average transit time. So these are the three which actually decides about the time in system. Again we can give weightage for these three, and in this case of ride quality we can see the maximum acceleration change and floor leveling error. So these are the three things which actually decides at the ride quality. So based on this we can give the weightage for these three, and similarly for availability also we can give weightage, mean time between failure and mean time between replacement. So this weightage also can be given. So once we give this, that actually shows that for this particular operational performance objectives, these are the sub objectives which actually contribute to the main one, and then we give weightage for each one. And then later on in the design stage, if you want to make some trade off between the MTBF and MTTR, we can find out, okay, these are got equal weightage, so we can make a trade off in any one of these. But in the case of here you can see that maximum acceleration has got a 0.3 and leveling error is weightage of 0.2. So based on that we can decide which one we should give priority to achieve. So, the objectives hierarchy helps the designer to understand or to make a decision at a later stage for trade-off analysis. Okay, so that was the first level where we developed the operational concept for the system, and once we have this operational concept, we need to develop the requirements for the system. For the requirement analysis, we can divide these requirements into different categories like originating requirements and derived requirements. The originating requirements are basically derived from operational needs. So, the operational needs are identified in the concept level. So, we know that do that particular concept, to implement that particular concept, there are some operational needs, and this actually defines the operational requirements. They are the top level statements defined in a language that is understandable to stakeholders, leaving substantial room for design flexibility. So, these are actually understood by the stakeholders, because stakeholders are the people who really tell, okay, what are the operational needs. So, the requirements also should be understood by them clearly. So, we should define it in a language that is understandable to stakeholders, leaving substantial room for design flexibility. So, this is one important aspect. So, we should not make it too rigid, the requirements, because then there will not be much freedom for the designer or much flexibility for the designer at a later stage. So, we should leave substantial room for design flexibility. And there are derived requirements which are defined by system engineering team in engineering terms during the design process. So, derived requirements are basically the requirements which are identified by the system designers, which are needed to satisfy the originating requirements. So, originating requirements alone may not be sufficient, because there are many other requirements, like there are external system, there are regulations. So, in order to meet all those requirements, the design team will identify some requirements, they are the derived requirements. Then we have these implied requirements, the requirements not specifically identified in the originating requirement, but can be inferred based upon available information. So, these are the implied requirements which are applicable depending on the system context and the environment in which the system is operating. So, these requirements are very implied, and they need to be included in the system requirements analysis. And then we will be having some emergent requirements, the requirements that are not even hinted in the originating requirements, but whose presence is made known by stakeholders later in the system engineering process. So, once we start the system engineering process, the stakeholders may come up with new requirements, saying that we identified some other requirements. So, we need to incorporate these requirements also into the system. So, these kind of requirements are known as emergent requirements. In the design process, we should have the flexibility to incorporate such requirements to the maximum extent possible, so that the customer will be happy with the system that is designed and developed for them. So, the requirements, as we mentioned, the originating requirements, derived requirements, implied requirements, and emergent requirements are all important in the analysis of system requirements. As you can see here in the slide, so this is the hierarchy of the requirements. As you can see, the top level is the mission requirement, which are identified by the stakeholders, and then based on these mission requirements, the originating requirements are identified by the system designers, which can actually be understood by the stakeholders. So, the stakeholders will accept, yes, this is what we want from this particular mission. So, these are the originating requirements. Then based on this originating requirement, the system requirements will be developed by the developers, system designers. Basically, need to address in particular requirement, we will be knowing where to go and how to, from where this requirement came, and we can have a close look at that particular scenario and then decide whether to really have that requirement or not. So, this is basically about the development of requirements. So, we need to actually go to the next level where we develop the originating requirements document. So, there are some procedures and some standard formats to provide this particular requirement. So, we will stop this lecture today at this point. In the next class, we will look at the writing of originating requirements document and what are the specific issues we need to address when we write the originating requirements document. Till then, bye.